All right, so next up we have animation. Animation's a really cool one. This is a really fun thing to do with your maps. There's not always a real purpose or reason, use case when you actually have to do animation, but once in a while it's pretty cool. I've done some really fun animated maps related to making World War II maps, like animating bombing runs over Central Europe, or things like animating flight paths, showing things actually moving or traveling or flying along roads, things like that. It's very cool. So we're going to go over how to do it in Leaflet and in MapLibre. As you might imagine, it's a little bit different between the two. This is a bit more advanced topic, but you might be surprised how simple it is in principle. Although to actually do it does involve a fair bit of like spatial analysis. So if you want to watch the videos that I've linked on spatial analysis using turf.js and things like that, there's a series that I started on YouTube, which I'm kind of dropping off at the moment. I'm going to turn it into a course instead. So stay tuned for that. Maybe when you're watching this, that course is actually done. Who knows? But this is going to involve some spatial analysis, so you're going to have to walk with me through that. And let's get into it. So as you saw when I started the markers up here, and then it moves along this line. So that, let's do it, and let's zoom in on the line. And we see that it zips along like that. Okay, so the basic idea here is that animation is just a really fast, like a film is just a really fast series of still images. Nothing's actually like moving on it. It's just a whole bunch of images that tricks your brain into thinking that it's moving. And it's the same thing with this. We're just changing the point so rapidly that it makes it look like it's actually moving. So to do that, we have to find every single point that we're going to set this marker to and set it in some kind of timed sequence, like every half a millisecond or something. We change the position to a slightly farther point along this line. That's the basic principle of what we have to do. So how do we do it? Well, in Leaflet here, we fire up our map and we have a line. So that is this line here. And that line could be anything, right? You don't necessarily even have to make that line visible. You could just not add it to the map, but I've put it here as a guide just so we can see what's up. And a basic map, our basic line, I've added it just with our GeoJSON method. Then I've added our marker and I've added that, and originally it's up there in London somewhere. Okay, then once we get going, we're gonna have this little thing called a set timeout. Set timeout, we might have gone over earlier in the course, I can't remember, but basically it just tells everything to wait for the total number of milliseconds that you write at the end here. It's a bit of an advanced function. It's something to look up. I'm not going to go over it in huge detail here, but basically you do set timeout and the function inside will run after 2000 milliseconds, which is 2 seconds. Okay, so after 2 seconds, because I just wanted it to wait a little while, and you can see that in the comments too. Feel free to, again, look through these code examples. I have tried to comment them with some information. I get the line that we have up here. So I get the line feature. Then I use turf, which is that library we've talked about before, turf.js, which has a whole bunch of spatial analysis stuff. One of the things it has is length, which will give me the total length of a line. So I get the total length of the line. Then here I say we divide the line up into, say, 200 parts. It's fairly arbitrary. We could divide it into 1,000. We could divide it into 10. The more we divide it into, the smoother the animation is going to be. But also the more points it has to generate and run over. So you want to find a good medium where you're, like you're not generating too many points because then it kind of might slow it down or have to do too much calculation, but you're not generating too few so the animation is choppy. It's probably better to generate too many than too few unless you're animating like thousands of things at once. Anyway, so next I get a section of the line. So what I do here is I divide the line up into 200ths. So I find, okay, the total length of the line, what's 1/200th of that? Ultimately, we're going to have to do 200 of those to get the total length of the line, right? So a single section of line is whatever the length of the line is divided by 200. Okay, then we do this set interval. This is an important part. Set interval is just like set timeout, where it runs after a certain amount of time, but set interval runs repeatedly. So it will run every X number of milliseconds until you tell it to stop. So it'll just keep running. If you tell it to console log hello, it'll just keep console logging hello forever and ever and ever until you reload the page or it's cleared or it's told to stop. So what I do is I set an interval to run every 10 milliseconds. So that's every 0.1 second. Is that right? 2000, no, that's 0.01 seconds, right? Something like that. Anyway, it's a very short amount of time. And basically what I do is, we can ignore this first part. At first, I use this function called turf along. This is quite handy. What we can do is take a line string and it will return me a point at a specified distance along the line. So if we give it a line and we give it a distance, it'll give me the point on the line. So if we had a line that was 100 miles long and we wanted to get the point that was 20 miles in, it would give us that exact point without us having to like do some crazy stuff to actually find that point, right? This point is just along this line, but it gives me it just knowing the distance. Now, since we've had this section of line going on, we know that that distance is going to be increasing by that amount every time we do a new animation. So what I've done is every time that we run this interval, every 10 milliseconds when this set interval runs, I increase this animation count by 1. And that's telling it, okay, you animated once, now twice, now 3 times, now 4 times, now 5 times. And that will tell me how far along the line I have to go. Because I have this amount of the line, and I multiply it first by 0, so it's at the very beginning, next by 1, so it's this far, next by 2, so it's this far, next by 3, so it's this far, and you get the point. It's slowly going the whole length of the line. And then based on what I get back from turf, I have to do some stuff with the coordinates because, again, we have to reverse them, latitude, longitude for leaflet, and I set the lat long of the marker. Okay, so hopefully that all makes sense, me walking through that code. So here we are at loads. Now I divide it up and it's going along each section of that line increasingly. And then at the end, I just say if the animation count is equal to the amount of, so if it's done it 200 times, I tell the interval to clear and stop. That's how that basically works. That's the principle behind what we're doing here. Now, we do more or less the same thing in MapLibra, only we use MapLibra methods, and there's a bit of a wacky thing you see here where it's not actually perfectly, it's not even close to actually being on this horizontal line. So, okay, let's go over the MapLibra one. We've already gone over the idea of the set interval and set timeout, so we're not going to go over that in huge detail. But there are a ton of examples with MapLibra on how to animate, so it's worth looking at these for detailed code examples of all of these. They have lots of them available because they know this is fairly common. So the first thing we do is we add a line. We make a line from, in this case, San Francisco to Washington. We just do a straight line. And we have a point which is starting at the origin, in this case, San Francisco, and that'll be our little circle. Okay, so we're adding 2 sources and 2 layers. One source is a circle, and one source is a line. Okay, so we add the source, circle, source, line. Okay, great. Now we do the same kind of thing. You see here divided into 200 parts, animation count, we do the interval. Okay, now we have to do this thing slightly differently here, which is instead of where we set lat long, there's this function where we can get the source that we've added and then set a new data into it. And we have to give it a whole new GeoJSON. So basically we're setting a new source for this. And this is a really handy little thing. So you could be animating a whole set of circles if you were to do this, because you're setting the data for the whole source, not just that one circle. In this case, our source is just one circle, but hopefully you kind of get what I'm talking about. Okay, so the basic thing that's different here is just that we're using this getSource.setData function instead of doing the marker.setLatLong. Okay, now just to kind of touch on why this doesn't line up, well, that's because of how turf works. Okay, and it's a bit of a bug, actually. I don't know, bug or a feature. It could be either, depending what you're doing. But the thing is turf is working off of knowing that the Earth is a sphere. And when I give it these 2 points, the closest distance, the closest way to get from one to the other isn't a straight line that you see like this, because this is a projected map, right? If we go to Google Maps real quick, and we hop on here and we zoom out and we look at going from California to New York, was it, or whatever, it goes like this, right? It's kind of like a straight line, but on a curved surface. So that means it's actually a curved line when it's on the flat surface. It's actually like this, right? And so turf is taking the first and last point and finding the way along the shortest possible line. And I think this is a little bit of a bug. It should really be doing it along the actual line that you give, whether or not it's the closest or not. But just something to be aware of, that when you're using turf, you might have to add a more detailed line with more points in order to make sure it's actually moving along that line, not just these two direct points. And we do see this in the example from MapLibra. If we hop over there and look at its animated point along route, I think this is the one that does something like what I'm doing. Yeah, see, they have the same thing, but they put a curved line, right? And this is generated a special way. It's more turf stuff, more spatial analysis. Anyway, the core stuff isn't really about that. It's about this whole thing with the intervals and splitting things up. That's how you really have to focus on doing animation. Hopefully this has helped, and we'll see you in another one.